Hi, I'm Sean Gannon, and this is Minute Math, and we have the famous Snowplow Math Problem. The problem is this. One day, it started snowing in the morning at a heavy and steady rate. A snowplow started out at noon, going 2 miles in the first hour, and 1 mile in the second hour. What time did it start snowing? Now, there's one thing we're going to add to this problem, and there's an assumption here, that the snowplow speed is inversely proportional to the height of the snow, meaning the higher the snow, the slower the snowplow goes. So I want to see if you can take a moment here and see if you can solve this problem. It's going to use some calculus here. But if you're like most people and you just want to keep on going through, well, don't pause this video and watch it, but I think it's worth your time to see if you can figure it out. Okay, enough time here. Let's go set some variables here. Let's set the variable t to be the time measured from noon hours traveled. Let's go set x of t to be equal the distance snowplow has traveled in miles. We have h of t, and that's going to equal to the height of the snow in inches. We will set the variable b to be hours before noon when it started snowing. And let's set K1 to equal the rate of snowfall, inches per hour. So now with this information here, they tell us in the problem that it's long and steady rate where the snow fell. So we can set h prime of t, right? The derivative here, the h prime of t, height of snow in inches, that rate, is equal to, we call K1, the rate of the snow falling. Then we know if we integrate that, or the antiderivative of, we have a linear equation, we have h of t is equal to K1 times time plus some constant c. Now, where does b come in here? Well, b is the hours before noon when it started snowing. So if we have h of a negative b, hours before noon going backwards, we plug that in for our time, K1 times time, negative b here, plus my c, and that actually equals 0 because right before the snow started falling there was no snow on the ground, being 0. If we solve this well for c, we get c equals to a K1 times a b. So with that being said here, we can substitute that K1 plus b back in for c into our h of t function here, and so h of t is equal to K1 times t plus a K1 times a b. And if we pull out a K1 here, we have h of t here is equal to a K1 times, and in parentheses, t plus a b. So to have more room here, I'm going to rewrite this up here and erase this part. So I'm going to rewrite that h of t here. Okay, this is where our assumption comes in here. The snowplow speed is inversely proportional to the height of the snow. So the snowplow speed we can write as x prime of t, and that will be multiplied by our h of t to equal some new K2 right there. Simplifying that to get x prime of t by itself, we have x prime of t here is equal to K2 over h of t, and h of t we know to be, well, our K1 times t plus b. So we have x prime of t here is equal to K2 over some K1 times a t plus b, right there. And well, while we're at it, we have a K1 or K2 over K1. Let's go make that equal to K3 to, well, simplify this up. So we can do that, and we can say a K3 is equal to K2 over a K1. And so that we can use, don't hear another equal sign there, but we can use that here to have a K3 over a t plus b equal to our x prime of t. So let's go write that information up here to have it saved. So we have an x prime of t is equal to K3 over a t plus b. Let's go integrate both sides of the equation. What we get on the left is just an x of t, and that's equal to here a K3 times the natural log of t plus b plus some constant 1. Alright, so let's go extract some more information from this problem. The snowplow travels 2 miles in the first hour. So, x of 1 here is equal to 2 miles, which is equal to our k3 natural log of a t plus b plus c1 from 0 to 1. We gotta take the antiderivative here. So in doing that, we have a 2 is equal to a k3 natural log of a 1 plus b minus a k3, the c1s will cancel, k3 natural log of just a b. And using our rule of logarithms, we can simplify this to be a 2 equals a k3 natural log of a 1 plus b over a b. Alright, I'm going to save this information here, put it on the side, and we're going to go to our next step. So now let's go look back again at our problem. It says the snowplow traveled 1 mile in the second hour. So what we can say then here is an x2 minus an x1, the distance it traveled, is equal to, well, 1 mile. And similarly before, we had the antiderivative, k3, natural log of a t plus b plus a c1 from 1 to 2. So being that, we have 1 equals, we'll plug a 2 in, we have k3 natural log of a 2 plus b, again the c1s will cancel, minus k3 natural log of 1 in, 1 plus b here. Again, this simplifies here to be a 1 equals a k3 natural log of a 2 plus b over a 1 plus a b. Alright, let me go write this up here and save that information for the moment. So again, we know that 1 equals k3 natural log of 2b over 1 plus b. Well, if we multiply both sides by 2, we have a 2 equals a 2k3 natural log of a 2 plus b over a 1 plus a b. Again, our rule of logarithms come in place here, and we have 2 equals k3 natural log of a 2 plus b over 1 plus b, all squared here. So now if we divide both sides by k3, we have 2 over a k3 is equal to that natural log of a 2 plus b over 1 plus b here, all squared. And if we do the same thing with our first equation here, 2 equals k3 natural log of 1 plus b over b, divide both sides by k3 there, we can say it's equal to the natural log of a 1 plus b over a b. So if these two arguments are now equal, the inside arguments are also equal. That 2 plus a b over 1 plus b squared is equal to 1 plus b over b. So let's go erase that and put that out here because I don't have the most space. Alright, so let's go simplify this. We have a 1 plus b on the left over b, and that's equal to a 2 plus b squared over a 1 plus b all squared. If we cross multiply here, we have a 1 plus a b all to the third power is equal to a b times a 2 plus b to the second power. So with that, let's go multiply this out. The left-hand side is a 1 plus 3b plus a 3b squared plus a b cubed. The right-hand side becomes a 4b plus a 4b squared plus a b to the third power. We simplify this, bring everything to the left-hand side, and we get a b squared plus a b minus a 1 equals 0. I won't bore you with the details there. With that, we can use our quadratic formula. b equals a negative 1 plus or minus the square root of 1 squared minus 4 times a negative 1 all over 2 times 1. And this simplifies out to be a b equals a negative 1 plus or minus square root of 5 over 2. So what do these two values come out to be? Well, we have b equals a negative 1 plus the square root of 5 over 2, which is approximately 0.6180. b is equal to a negative 1 minus the square root of 5 over 2, and that approximately is a negative 1.6180. Well, what is B again? Well, B is the hours before noon when it started snowing, so B will have to be positive. So B has to be greater than 0, so we cross off our negative value here, and so our B value is a 0.6180, and that's the hours before noon. So if you want to find out how many minutes that is, approximately 0.6180 times a 60, minutes in an hour, and that comes out to be a 37 minutes overall. Again, 0.6180 was in terms of hours, we need it in minutes there. So 37 minutes before noon is our final answer for when it started snowing, this whole shebang here, and that time comes out to be about 11:23 a.m. And there we have it. There's our answer. Did you get the answer? If you did, let me know down in the comment section below. And if you thought this assumption was tricky or not fair, let me know, but that's the way we had to solve the problem. So, as always, thanks for watching. And it's inversely proportional to the height of the snow. I'll start with x prime. We plug that into our, well, we need to take the antiderivative here when we do that. From here,